Quantum Computing by Shawn Welsh. Computers are an integral part of our lives today. From work to play, they open new doors and new possibilities. Much of the technology that we have today is rooted in the advancement of computers. And as they continue to advance, so will everything else. Think of where phones, tablets, cars, and many of the other things that we use every day will be in 5 years, 10, or even more. Quantum computing is one area we will see a major advancement in. It will affect the way we view technology and the impact it can have on our lives. First, let's talk about modern computing. The earliest computers were large enough to fill giant rooms and could only perform very simple tasks. Over the years, computers have advanced so far because we have learned to make them smaller and make the processors faster. By combining more, faster processors on a smaller chip, you get a greater speed for your computer, and the footprint is much smaller. We've gotten to the point where computer processors are so small and use so little power that they can fit in a smartwatch or in the phone in our hands. But there is a limit to how small they can be made. Intel is expected to release their new 10 nanometer chip this year, the smallest ever. But where can we go from such a small chip? Quantum computing is the solution to this problem. Modern computers work by measuring bits, which have a state of 0 or 1, on or off. Bits are combined into bytes, kilobytes, and so on. A single byte may store up to 256 distinct values. Quantum computing leverages qubits, which abuse quantum mechanics to be on, off, or both. These three states bubble up into much greater storage and speed in the actual computing level. A qubit stored in a byte would be 6,561 distinct values. There's a significant increase in storage even at the most basic levels of computing. Since we're dealing on this quantum scale, that 10 nanometer processor chip would seem enormous compared to the quantum scale. So quantum processors will be able to fit into much smaller spaces, consume much less power, and be significantly faster. According to DiVincenzo in Scientists and Citizens Getting to Quantum Technologies, the point we have reached now with miniaturization of processors is what will enable us to tackle the problems we will face with the scale of quantum processors and their production. According to Horsman in The Natural Science of Computing, as part of the transition to quantum computing and other unconventional computing methods such as biological computing, we will have to modify what our views are on traditional computing sciences to integrate these new technologies and use them fully. Some of the technologies we will see affected by quantum computing are medicine, engineering, and automation. Medical advancements from quantum computing will be huge. Chemists and biologists already use computer modeling to predict the outcome of drug tests, viral growth patterns, genetic mutations, and many other things. With a significantly massive increase in computing power from quantum computing, modeling will be much faster and much more accurate than it is now, allowing research to proceed much more quickly and much more reliably. Automation will also see huge gains in the complexity of algorithms required for self-driving cars, delivery drones from Amazon, and other things that will have much more powerful computing than ever before possible in a much smaller footprint. Quantum computing will change the face of our world and how we view and solve our problems that we face every day. In conclusion, computers have significantly changed our world as they have become more advanced and penetrated into our everyday lives, and they will continue to do so into the future. Quantum computing is coming, and so is the future we have seen in science fiction media for so long.